All right. Hello, everybody. So thank you, all y'all, for coming to the February Policy Simulation Library meeting. So just like every other meetup so far, we're going to have a couple of updates from members of the library, before we get into our main presentation with Mart and Holmer on the tax calculator model. And of course, afterwards, we're going to have a small social. If you want to hang around, mix and mingle, there'll be a few snacks and drinks for you to enjoy. So first up, we have Matt Jensen of the Open Source Policy Center to give you a quick update on some of the work that they're doing.
Thanks, Anderson. Thanks, everyone, for coming. I'm Matt Jensen. I direct the Open Source Policy Center here at the American Enterprise Institute. I'm also a contributor to the Policy Simulation Library, and I'm a contributor to Tax Calculator, so I'm excited for everyone being here to hear about PSL and hear about Tax Calculator. But what I want to give you a quick announcement about today is that the Open Source Policy Center has a new website, thanks in large part to work by Peter. I don't know where is Peter? Peter went to the other room. Thanks to a large part to the work of Peter Metz, we have a new website. Open Source Policy Center, we basically do two things, three things really. One is we host the PSL meetups at AEI. Hopefully we'll have some more PSL meetups at other locations hosted by other centers soon, but for now, OSPC is the only game in town if you want PSL events. The second thing we do is we work with young projects that do open source modeling for policy, and we help them develop to the point where they're very user-friendly, and we help them develop user bases in DC and elsewhere for using their projects. And so if you have a young project that works in an open source policy area, feel free to get in touch with us. You can see some of the projects that we've worked with in the past on our brand new website at ospc.org/portfolio. And so there's quite a few, many of which you have heard about already at these PSL meetings, and some of which you'll hear about in the future. The last thing we do is the OSPC does is we have a little newsletter that we send out every couple of weeks with news from all sorts of open source modeling projects in DC, primarily focused on public policy. The idea behind it was basically that working at the Open Source Policy Center, thinking about this stuff all the time, there's actually a lot of really cool stuff going on around town that has nothing to do with what we're doing. Some of it does have to do with what we're doing. We put all of it in the newsletter just because there's no other aggregator that'll say, like, okay, you want to hear about some cool open source models for policy analysis, here's the website you go to. That doesn't exist as far as I know, and so we hope that our newsletter can help fill that space. So go to ospc.org, check out our new newsletter, and put in your name and last name and email address and sign up for our newsletter if you're interested. That's all I've got this morning. Thanks again, everyone, for coming. Hank, I think, is up next.
Hi, I'm Hank. So just wanted to introduce a project I've been working on over the last few months called pramtools. It's a library for parameter processing and validation, and it's actually a product of spending a lot of time working with Martin on the tax calculator, parameter processing, and validation. And so I've kind of tried to take a step back and generalize that and make that functionality available for all projects. So I'm going to tell you a little bit about what problem it solves and why you should care. So here's the GitHub repository. In this repository, it gives you a little description about what it does. It walks you through a quick example, and then you come down, and there's some instructions for installing the project and a link to the documentation. All right. So first, why should you care about parameter inputs and processing, and what problem is this solving? And so the way pramtools works is you define the inputs for your model in a JSON file, and in that file you have for each parameter you say what the parameter is called. You give a description of the parameter. You say what type it is. Is it an integer? Is it a floating point value? Is it a Boolean value? Is it a string? What values can it take on? And so, within that file, you learn everything you need to know about that parameter. And so, here's an example for this that I put together for just like a toy weather model. And so, from this JSON file, if you can see, like for this average high temperature, you get to see. Like a quick description. There's the float, or you get a type. It's an integer. For the different values, it says you get these different dimensions. For if it's the city, the month, day, month. So it's all kind of there, and it tells it, and you get like you also get the range for the values, and so all that information is there. And so all right, so everything's documented there, and your user can see everything about the parameter there. And then so how do you use it? Well, you subclass this pramtools parameters class, and you tell it where your JSON files are. There's a schema file which defines the parameter space for your model. It tells you what dimensions are there, what values are allowed. There's a defaults file which says the default values for your model. Maybe if it's a tax model, then you have like just the current law values are there. And then and so from that file, pramtools implements the spec, and so then you can create this class. You can set the state for the class. You can say like which parameters are active, from specifying the values for the different dimensions. The values of the parameters are accessible from the instance attributes. So from you can get the values for the average precipitation and Atlanta and DC as an array just by accessing the variable name. If the user, whoever's using your model, they can update the parameters, from this sort of similar JSON structure, and so you can change the default values, and then you print the values out, and you can see that they've been updated. Say you have a lot of people are using your model who didn't develop it and they don't know what the parameter values should be. Then if they enter a value that's out of range, or if it's the wrong type, then you get an error message. So in my example, someone tries to set the average precipitation level to rainy, and you get an error and it says, hey, that's not an integer, that's not going to work. And so you get a lot of functionality like that. There's an entire JSON specification and documentation on that. Defines all the objects in the JSON file. So the documentation is a work in progress. I'm trying to get that going now, and I've been working some with Peter on a new project that he's doing, and he's given me a lot of feedback about how I can improve the documentation to better communicate what this project is. Like how can you use pramtools with your project? How do you plug it in with your model? And so I'm trying to get a guide out on just how do you do that. So so over the next few months, I plan to just improve documentation. I'm excited for people to use this and see what use cases are out there, and what things I need to cover that I'm not covering yet. So anyways, that's pramtools. Thank you.
All right, thank you, Matt and Hank, for those updates. So now we have our main presentation. So today we have Martin Holmer. Martin Holmer holds a PhD in economics from MIT and has decades of experience working in microsimulation models in a variety of fields, including health insurance plans, Social Security reform, and employer-sponsored pension policy. Most recently, he's been the core developer on the open source tax calculator model, which is what he is here to present today. So, all yours.
Thank you, Anderson. So the format today is that Anderson's going to do the heavy lifting in a few minutes after I run through a few slides. Just to give you a brief overview. I can move if I'm in the way. Is this better? Can everybody see either screen? Okay. So the basic idea here is that we have the policy simulation library has an open source microsimulation model that's just for static tax analysis. We'll talk in a minute about how it interacts with other modules to do non-static analysis. So if you are not familiar with it and this presentation gives you some interest, the place to start reading on the web is that URL, okay? So I guess this presentation will be available, so you don't have to write it down. So what are the key features? It does individual income taxes and payroll taxes. The second bullet, to my mind, is the key distinguishing feature of Tax Calculator. Unlike a lot of other projects here in town that are focusing on individual income and payroll taxes, it's being made publicly available in a way that the user can change all kinds of tax parameters. The tax brackets, the tax rates, you name it. And so currently there's over 200 parameters, and you can change all these. So that means that anybody that's using this can specify an enormous variety of tax reform proposals. And so to me, that's one of the distinguishing features here. Another thing is you can use different input samples. We've got something like most people use here in town, which is derived from the IRS SOI PUF file. Add a few CPS records to represent people that don't file. We've also come up with a pure CPS sample that you can process. But the key thing here is that you can also create your own data set and feed it through. So you're not tied to the two that we've made publicly available. Well, we haven't made the PUF because IRS makes you pay for it. But if you paid for it, we're happy to share our version with you if you're okay with IRS. So another key thing that we'll talk about on another slide is that this tax calculator is packaged in 3 different ways to cater to different users. We'll explain that in more detail. So there's a real simple version, and then there's the most complex. It's more complex, but you have more flexibility. So there's a trade-off. Anderson is going to, in his demos, he's going to show you the simplest and the most complex, both, okay? And of course, it's open source. It's written in Python, which is pretty popular, being taught a lot in universities now. So what does that imply? A number of things. One thing it implies is that you can see exactly what we're doing, for better or worse, right? It's not a black box. You don't have to read English documentation to say, what do they mean by that sentence? What is actually going on in the code? We have some documentation, but you can also see exactly what's going on in the code. And the other thing that's interesting about the open source nature of this is that it's extensible. The example I give here in the slide is that if you're using it, you can download the source code. You could add, instead of asking us to add a new policy parameter, because you have a reform that requires something brand new, that we don't have among our 200 plus parameters. You could do it yourself. Or you could write in and ask us to add it. Another extensibility is that Anderson and I went to New Delhi for a week in September, I guess it was. And a few days of work before and a week with them at the Tax Policy Research Unit, which is part of the Ministry of Finance in India. We stripped down this model that we're showing today and to its skeletal structure and put in the details of the personal income tax in India. So they have a version of this, right? So that's another example of the extensibility that you get when you're doing open source, okay? So what I mentioned are the 3 packages. So there's an internet-based app. It's called TaxBrain. And Anderson's going to show a simple application of that, so you get to see the look and feel of that. There's a computer command line interface. In other words, if you don't know Python and you want to do something with the output of the data that's more elaborate than what you can do on the website, then we give you something where you just type commands. You don't need to know, you need to be comfortable working at the command prompt in your operating system. Runs on Windows, Mac, or Linux, so whatever you want. And you have to write some reform files, which you're going to see examples of in Anderson's demo. So you have to be comfortable working with an editor. But you don't need to know any Python. You don't need to do any Python programming. So this middle interface was actually used more than a year ago during the TCJA legislative process. There were a number of graphic journalists at the New York Times and the Wall Street Journal, not the Wall Street Journal, Washington Post, some other places, who used this command line thing. They didn't know anything about Python. They were into JavaScript because they were into interactive graphics. And so they created their own data sets to illustrate the points they wanted and created these pretty impressive interactive graphics for the online version. And the library that we're talking about here is also packaged just as a Conda package. So you can just download that. You don't need the source code. And we have the documentation of what the API is, and you can write a Python script. In other words, you can create your own app. That's the point. Okay, so what about interacting with other models to do non-static analysis? Here's the roadmap where we are now. We're starting out on this, so we're not very far along yet. But we do have a behavioral response module that interacts with us. What I mean is, by interact, is a lot of things can use tax calculator, but not everything feeds back information to tax calculator so that the aggregate and the distributional results reflect the behavioral responses. So this is things like if you think much higher tax rates are going to have a labor supply response, and so maybe some high earners who are facing higher tax rates are going to report less earnings. Well, this is the kind of tool that you would use. And one of the presenters from a couple months ago here at this meetup was Cody Kalin. He's now a graduate student at the University of Wisconsin in the economics program. He's written a business taxation model that models corporate income tax reforms. And I'm working with him so that we can feed back the effects of that onto individual incomes and either property or labor incomes changing, and therefore recompute the effects of that at the individual level. And eventually we hope to have a modest macro feedback module that will allow sort of dynamic growth effects to feed back to people's incomes and therefore taxes at the micro level. That's it. So it's all Anderson now. He's going to do the demo. Maybe I'll go. You're gonna switch things. So.
Yeah.
Okay.
Okay. So, like Martin mentioned, we wanted Tax Calculator to be as accessible as possible to as many groups of people and researchers as possible. So one of the first things that was actually done with Tax Calculator was creating this website, TaxBrain, so that even if you have no technical expertise whatsoever, but have a relatively good feel for tax policy, you can go in, enter your new policy reforms, and get some kind of output to present. So we start by, pretty simple, you can update the start years that you want to run, or you can use different data sets. So we have that public use file Martin mentioned from the IRS that we're not allowed to give away, but we were able to build into this website. Or you can do the publicly available file based on the current population survey, whichever works. So we're going to use the PUF for this instance. And you see over on the left-hand side, we have a variety of areas of the tax code. So like the standard deduction, itemized deductions, personal income tax rates, and you can click on any of these and go straight to that section of parameters to update. But as you scroll down, you can also see them all individually. So you see we have a few labels, like, for example, the Social Security tax rate, and then you can just click in the text box and enter a new amount. So let's, for example, raise that to 0.14 instead of the default value. And you can see the default value underneath the box after you edit it, as well as the change in color so that you know that you've made some kind of update. And as we keep going, you can see there's above-the-line deductions, personal exemptions, standard deductions. Pretty much every aspect of the tax code we have included in the model. And then a few extras that were proposed during presidential campaigns or congressional campaigns that aren't part of the current law, but were proposed at some point, and therefore we wanted to make sure that it was possible for you to run reforms including them. So we've made one change already. I think that's plenty for the demo's purposes. So once you've made all the changes that you want, you can just click Show Me the Results. And it'll take a couple minutes to run. So you've got this just sitting on an AWS server. And it'll go through, run the model for a 10-year time span. Usually only takes a couple minutes. Every now and then the website gets pretty busy, and it will take a lot longer. During that TCJA debate, we had a few days where it would take like 30, 40 minutes to run because everyone was on there running it. So, but we got it estimating, should be about a minute left, not too much longer. They've done a really great job sort of optimizing the website to run everything relatively quickly. Getting a full 10 years of results from a model in a couple minutes, I think is pretty impressive. And for people in like congressional offices or on presidential and congressional campaigns, when they can iterate through policy like this really quickly without needing to get deep into the weeds of a model or wait hours on hours while these models run or anything like that, I think is a really great sort of feature to have. And we've seen over time a lot of different groups take advantage of it. So once that model finishes running, you get a pretty basic output. It's going to tell you what your reform is and what changes you made. So we only made one change here. We just changed the tax rate on Social Security or for Social Security taxes. And as you scroll down, you get a nice 10-year table showing the changes in individual income tax liability, payroll tax liability, and the combined. So you can look at either the change in it, or if you want to click over, you can look at the total liability under the reform or under current law. And you can also download each of these tables as a CSV or an Excel spreadsheet if you so wish. Further down, if you want a little more detail on the reform that you made, you can look at distributional tables where we've broken down the impacts of various reforms into income bins. So, those between $0 and $10,000 in AGI or expanded income, everyone has a row, and each row has a number of features, including the number of tax units in that bin, the number who receive a tax cut, number who receive a tax increase, and sort of what portion of the changes in tax liability falls on each person in that bin. And what I think is probably the coolest part about the output is you can also customize it a lot. So the default just shows you differences in the change in tax liability. But if you wanted to look at a more at another output where you could see how many people are filing for the standard deduction in an income group, or how many people are itemizing, or how much total taxable income is in an income group, you can just click a couple buttons and get all of that information. And we have all these columns over here to look at as well. So it's a very sort of nice, easy to use user interface for people who don't necessarily want to learn how to program in Python, or don't have the time to do that, and just want a quick, simple analysis. And of course, it's all available. And when you run a reform, you're going to get a unique URL, so you can at any time go back and view the results over and over. As you can see in the link, there's a number at the very end of the link. So yeah, if we go back one number, we'll see the reform someone ran like this morning or something. So once you've run the reform, it's always there for you to go back and reference. So as kind of mentioned, that's the easy way to do it. We're going to skip over the intermediate way and go straight to the more advanced way, which is actually writing Python scripts and writing these what we call JSON reform files that just specify what kind of reform you're testing. Okay, so is this large enough for everybody, or you want it a little bit bigger? Good. Okay. So right here we have, just to start, this what we call the JSON reform files. So this is how, if you're writing everything in Python as a Python script, you can specify what policy you want to run. So in this file, the policy we're simulating was actually proposed by Rep. John Larson as a way to increase Social Security's funding long term. So he wanted to do three main things. First, raise the threshold for Social Security benefit taxability. Then he wanted to make wage and self-employment income above $400,000 subject to FICA taxes. And then he wanted to phase it an increase to the contribution rate starting in 2020. So to sort of see what would happen if all that happened, we wanted to create this JSON reform file and plug it into the tax model and see what we got. So creating the reform file is relatively simple. There's lots of pieces, but it follows a very basic, simple and consistent format. So you got to first just say that this is a policy change, not a change in, say, the growth rate of wages, because you can do that as well in the model, but that's a little beyond the scope of what we're doing today. So say it's a policy change, and then all of these, what looks sort of like random jumbles of letters and numbers, they're all different policy parameters inside the model. So each one is a variable name, essentially, in the code itself. So you're going to specify the name, and then specify the values that you want and the year you want them to go into effect. So we're having most of these go into effect in 2019. And then, for example, this is one of these Social Security taxable income thresholds. And there's going to be a different threshold depending on what kind of filer you are. So you specify first for single filers, then joint filers, married filing separately, head of household, and so on and so forth in each column. But then there are the variables that just have like a single value, so like the tax rates. So as I mentioned, part of the reform was increasing gradually the contribution rate for FICA taxes. So when you want to do some multiple year change to a certain policy parameter, you can easily do that just by specifying the value for each year. So our model goes out to 2028 now that we've actually released the 1.0 version on Friday, I guess it was. And so each year you'll just specify a value. And pretty simple, very straightforward. Once you've done that, you can start writing the actual Python code to run the model. So I've done that in this file over here. You start pretty basic. You import the package, import a couple other packages that are just kind of used to make it like display prettier when we actually run it. But from there, after you've imported the tax calculator package, there are really three main things you need to worry about for it. There are the records, policy, and the calculator itself. So the records handles all of your data. So every row in that records object is going to represent a tax unit. And it'll have the information on their wages, their age, their filing status, and basically anything else you would need to kind of see on a tax form. This policy object is what handles all of the tax law parts of the model. So it's going to have information on all your tax rates, all your deductions, and everything else that is part of the formal law. And then when you want to update and change the different parameters, that's what you're going to be working with as well. And then finally, you have the calculator that sort of brings it all together. This is what's going to process the policies and apply them to each record in there. So after that, we want to read in this JSON file so that we can plug in the parameters we need. We've written a short module for that. It's called read JSON param objects. All you need to do is specify the file name, and it will handle the rest and return to you like a Python dictionary with all the information that you need. From there, you can simply, you just use this one method, implement or form, and everything internally is handled by the package itself to update all those policy laws. Then just make a new calculator, and you're good to go, ready to run everything. So most of this is kind of boilerplate stuff I just wrote to store the results, so you don't need to worry too much about it. What we're doing here is just looping over those 10 years, and we're going to advance the calculator to whatever year we're on, run it, and then this is all just collecting results from there. So right now, all we're really interested in is the total for individual income tax liability, payroll tax liability, and then that combined liability. So that's all that's happening in this loop. It looks a little more complicated than it actually needs to be. These 4 lines are really the only important part. The rest is just collecting that aggregate output. And then this is all just making it nice for when we output it as well. So now if we go to actually run it, simply, oops. Okay, there we go. Maybe. So we're going to run it. Depending on your computer, it may take a little bit longer or a little bit less time than the web application. Or it depends. But right now, that exact same calculations that you saw where it had the progress bar going on the website are happening. So as soon as you start, that calculator object is going to print out saying, hey, you've loaded this data. It's for this year. And now it's just doing all the processing and running through that 10-year loop. So it should take a little bit longer. And what we're going to see as an output is just 3 different tables that show you the aggregate tax liabilities under current law, under the reform, and the differences in those liabilities. And I think it's going to print out a little weird just because of sort of like the terminal window we're running it in, but you should get the gist of it. Okay. So here we have these 3 tables that were produced. So you have the baseline revenue in billions for all 10 years, the reform in billions as well for all 10 years, and then you can see the change in billions again for all 10 years. So this is the kind of thing you're going to see in a lot of those reports from like the CBO or JCT when they're doing this tax analysis, and it's now available to anyone to produce themselves. So I guess with that, we can start taking questions. If you do have any questions, please wait for the microphones. I don't know who's giving this out. Yeah, and then I guess, Martin, if you want to come up and... So, cool. Yeah, you can just give it 1 second, then they'll bring the mic over to you.
I don't know whether it came through very well or not, but the reason when we did the example on TaxBrain, the web app, that it ran faster than what here is that what's going on up on the web app is that because it wants to compute 10 years of results, the sort of standard window, it actually distributes each year to a different Amazon Web Services instance and then puts the results together. So there's a kind of parallel or distributed processing going on. Okay.
Mark Tiny, Mathematical Finance Company. Is it possible to do back testing where you start, say, from 2010 and run it forward and compare to actual historical data for that time period? Is that feasible?
Yes, yes it is, and we've done a little bit of that. We probably should do more. We have policy parameters only going back to 2013, so we can't go back to 10. But IRS publishes some fairly detailed aggregate and by AGI groups of various components of the personal income tax, the individual income tax. And so I've actually tried to reproduce those tables, see how close we can do it. I think I did it for 2015, which at the time I did this maybe a year ago was the most recent thing IRS had put out. And I compared the CPS with our PUF thing. And the PUF thing did quite well, as you'd expect, since it's, it's the filing records. The CPS did not as well on everything because it doesn't have the advantage of the oversampling of the rich people and all the property income detail that you have with the PUF. But yes, we have done that, and we feel good about what's happening.
Can users do that, or?
Sure.
So we could.
Because this third thing, which I probably didn't explain very well, is the way you get access to do what Anderson just did, is you download a package, as it's called. It's like a library. And you don't have to have the source code. You can just go to our website to see all the documentation. So you can, and look at the source code, but you don't need to have it on your computer. You just download this, this company in Austin, Texas called Anaconda, big Python company. They have what they call Conda packages. It sort of puts together your whole project and makes it easy for people to download just the package. And then you use that. So go back up to the source code. At the very top, he said import TaxCalc. TaxCalc is the name of the package for tax calculator. So you can download that. So then once you have that, you can write, if you're willing to get up to speed in Python, you can write any program that uses it you want, including this comparison.
And the structural parameters year by year, you have those in some file starting at 2013?
Yes. That's another thing that maybe is not crystal clear from what I said and then the presentation of the demos. We have a file that has current law policy for every year since 2013. And if you don't specify a reform, in other words, you have an empty reform file, then that means you're running current law for whatever year you say you want. The reform JSON file, this is basically saying, I want to run current law except for these changes. That's the basic idea.
Can it be, like, let's say you started at 2013. Is it time varying? So
yes.
Each year you have the historical structural parameters for that year?
Yes. And the reforms can also be implemented gradually, like this 0.1% increase in the combined employer-employee tax rate in Larson's proposal. So yes.
Okay, very nice.
Any? Okay, that's good.
Back there.
Okay.
James Sang, retired. Just curious, are the input parameters like your IRS input parameter or the CPS good enough to allow you to look at the impact of changes in the tax code on revenues produced in localities or individual states?
We have a whole nother group that's worrying about these issues. But out of the box, I think the IRS PUF doesn't support that. It has no geographical code on it at all. So Matt could probably, if you're interested, speak to you about our efforts there. Or maybe this will be a future meetup topic. But we are spending time on that. Because the answer is no.
Is this year's tax, of course, has a $10,000 cap on deductions, on local deductions.
Right,
so
right.
I'm curious how, if you varied that, how different areas would be impacted.
Well, let's go back to one of the things I mentioned, which is you can generate your own data. So I believe it was the guy from the Washington Post. He was a whiz-bang JavaScript, I think, because all these interactive graphics on the newspaper's website are done in, what's it called? D3?
D3.
D3. It's a interactive graphics package that's for JavaScript. And JavaScript by itself, despite its name, is quite a general purpose programming language. So this is what these people know. They're not into Python. So we showed him how in JavaScript he could generate, I think the guy from the Post generated slightly over 200,000 records. And he specifically did it from this angle that you're talking about, where he put the state and local taxes and real estate taxes high and low, and said this group represents people who live in New York, and this group in California, and the rest of the people in the Midwest where they don't have very high state and local taxes. And so he was able to show this with his manufactured data. Well, I don't know what he looked at to get his manufactured data realistic. But he seemed good, so I would imagine that he did look at some kind of other statistics to get a sense of how he should generate this sample of his own. And then the one thing that we didn't show is the middle thing, where you just use the command line. You point to the reform file, and you point to your own input data file, and boom, you get the same results. One final thought. What they did for the graphics is not aggregate like the demo did here. They got a dump of all the information, all 200,000. And there was actually, they had a scatter graph that showed where, and you could actually put the mouse on and see the details of each one of the 200,000 records. So that was all done at the micro level to give you kind of a pretty cool data visualization.
Hi, Ari Diaku. I'm a proto-lawyer. I sort of missed what the model's doing. Is it sort of doing 300 million tax returns?
Yes.
Is it simulating the economy, or?
It's your first thing. It's basically TurboTax on steroids. It's hard to do more than one return in TurboTax. But this is, you have to go through the interview or fill out the forms, whichever mode you're into. So what this is basically this is a simulation model of filling out a 1040 form plus the payroll tax details. And we have this representative or non-representative sample. You can just put one or two people. If you want to illustrate what's going on, how this person is going to be affected by the reform very differently than a second person, you could just create two records and say, here's what it would look like. Which is, that's a tradition in Social Security. I mean, the chief actuary of the Social Security Administration puts out their distributional analysis is not based on microsimulation. It's typically built on, is it 3 or 4 stylized individuals? I say, oh, this reform is going to affect this person this way, that person that way. So you can do anything you want. Any other questions? Yeah, here.
Tyler Sizer from the Committee for Responsible Federal Budget. We use the TaxBrain a lot. It's a great tool. It's a question about how you do the future simulations. Is that based on like CBO's economic growth assumptions, or if you just ran current law, does that would it give you numbers that sort of match what CBO is projecting tax revenue to be?
Yeah, I guess I could take that one. So we do have a bunch of growth rates built in here that are based on the CBO 10-year economic projections. And then as we go through them from year to year, we just apply them to that data set of tax units. So we're going to blow up everyone's wages by like the average projected growth rate by the CBO. And then that's also for factors like inflation, for like the standard deduction, for example, which is indexed. We have inflation parameters built in as well that will blow that up over the 10 years. And we didn't get into it today, but there actually are ways to also sort of edit those numbers. If you think, say, wages are going to go faster than what the CBO is saying, you can go in and change that parameter as well to see how that would change outlook as well.
So if either you or we were interested in adding like 2029, because that's now the new 10-year window is, 2020 through 2029, how difficult is it to sort of add one more year?
So I've done it a few times now, and it can be done in like a couple of days, tops. It's not. It takes. I think the hardest part is like figuring out exactly where to plug things in, but it's pretty simple. You're gonna have to go into what we call tax data as well, which is sort of like all the Python scripts that feed in data and growth rates and the weights for all of this. I can get more details with you afterwards as well, because it gets pretty in the weeds. But it's relatively straightforward.
Okay. Well, I'll throw that as a recommendation that's useful for policymakers. Is that since that's a new budget window, you might want to think about adding 2029.
Right. So we have 2028 now. So we wait on. I don't know if the CBO's released the 2029. Have they?
They have.
Okay, perfect. Then that would be my next week.
Well,
so we'll work on that.
Yeah.
We just released the 1.0 version of TaxCalc, and that bumped it up to 2028. Right. So, yeah, 2029 is now going to be in the works.
Yeah, that's a good question on substantive and also procedural aspects, because I think I alluded before saying, well, it's extensible, so it means if you want to do Python programming, you could add a policy parameter and so forth and so on. But the other choice that I alluded to is often the better choice, which is to just become a free GitHub member, and you could just say, hey, you raise an issue and say exactly what you just said right here. Wouldn't it be nice if you could do this? And then that would get us focused, and we'd say, oh, well, is the CBO out? And the answer is yes. So, we'll put that in our queue, our work queue. So making suggestions, making requests, reporting bugs because you think that tax calculator is producing sort of screwy results. That's all what you can do at GitHub. You don't need to know any Python. It's like a social network. You just go in and say, I want to create a new issue, and you start typing in a little editor window, and you don't have to know anything about it to ask a question or make a request. Or if you've been doing some, detailed work and you find puzzling results, then you want to say, this doesn't look right. So as we speak, I'm actually working on a bug fix because a user of what started just last summer had already found that there's a little flaw, not in the basic bottom line results, but she was looking at the variables that are the components of total itemized deductions, and they didn't look like they made sense. Total looked sensible, but the components, and that's because we hadn't handled the adjustment, like when there's a piece-like limitation. We got the total down to the right amount, and that's been validated against other models. But we didn't have the component scaled down. So that's something I'm fixing this week. And so it was better for her to raise it to us than try to grapple with it on our own.
Mark Tenney again. The scenario you presented here, I was wondering if you could walk us through what happened. As I recall, we increased the Social Security rate from 0.124 to 0.14, So the payroll went up and starting in 2019 and up to 228 by 2028, but individual income went down. And I'm wondering, but it went down a lot in 2019, but by 2028 it's only down by 43, whereas the payroll's up by 228. Could you just, maybe this is unfair, but can you explain the logic of how that happened, or what sort of models?
Yes, that was part of the reform. So the first aspect of the reform was they increased that threshold for when Social Security income becomes taxable. So by increasing it, there's just less taxable Social Security income, and then your individual income taxes went down.
The first two lines there, the threshold for the part of your Social Security benefit, well, it used to be, before the 83 Social Security reforms, that none of your Social Security benefit was considered taxable under the federal income tax. But the 83 reforms, they said, no, if you, we're going to introduce 2 thresholds. And if you're above one, half of your benefit is going to be included in AGI. And if you're above the other, then it's going to be 85%. Correct me if I've got this wrong. But anyway, that's the gist of it. So now for some people, part of your Social Security benefit is part of taxable AGI and therefore taxable income. So this reform, one aspect of the reform, besides increasing payroll taxes in 2 different ways, the base and the rate, it's cutting down the number the number of benefits that are going to be included in AGI. So that by itself reduces individual income tax revenue. Fewer Social Security benefits are going to be taxed. Does that make sense? No. Okay, I'm not doing a very good job. Okay. Social Security benefits, some get included in taxable income. This reform reduces the number of Social Security benefits that are included in AGI. And if AGI goes down, everything else the same, tax revenue, individual tax revenue is going to go down. See, we're making a distinction here between individual income taxes and payroll taxes. Clearly, the payroll taxes are going up. But the individual income tax is going down because part of the reform is to tell certain people whose Social Security benefits are now taxable that they aren't going to be taxable anymore. So their AGI is, for those people, their AGI is going to go down. Okay. So in aggregate, there'll be a slight reduction in aggregate income tax revenue. That make sense?
Okay. I think so.
Okay. No?
This may be way too wonky, so if you've got it, I can do this afterward too. But if you had like 2 separate policy proposals, like, you know, this one reduced the income tax on Social Security benefits and also some other income tax change, is there a way to get the aggregates from each policy change separately?
Well,
because just from a budget perspective,
sure.
The Social Security benefits would go back into
There's nothing fancy about it. You just decompose your aggregate or your bigger reform into different reform files that are each provision.
Yeah.
So if you wanted, like JCD does, a line-by-line thing, we don't have anything automated that does this. Right. There are some people in our group that are dreaming of creating such a tool, but we don't have it yet. But what you can do is do it by hand, by just taking each one of these 3 provisions, the base increase in the payroll tax, the rate increase, and the reduction in Social Security benefit taxation under the income tax. You could separate those 3 into 3 reform files and run them individually, and then you would see how each one worked by itself. So you would see, and then you run this, you get the effect, so you're going to see how much interaction stuff is going on in some reforms.
Okay.
You could also run you could run the first provision and then the first 2 provisions and the first 3 provisions if you wanted to capture this.
Right, and that's, in this case, it just made me think it's a trust fund thing, right? Like the stuff from taxing benefits goes back to Social Security.
Yes, that's right.
Even though it's income tax, so.
That's right.
Awesome.
Got one more.
With this question about multiple simulations, I'm going to get back to the parallel processing you talked about. You said on the AWS server, it runs, on different instances. Is it program, if I was doing it command line or, via Python, does it use all 6 of my cores by default, or is it a couple day fix to turn it parallel?
So you can just so by default, it's not going to run it in parallel. So like in the example, we have a for loop that runs through, does the calculation for 1 year, goes to the next one, does the next. But you could use something like the Python package dask, and when you're writing this Python file to run your calculations, run it so that you sort of set it up in parallel. So you do need to know something yourself about parallelization, but it's definitely possible. It's just not built into the package by default.
And I'm not a Python user, so Python doesn't have any parallelization, even the stupid versions.
They might have some in the latest version. They have like this async thing. That's
okay. Cool.
But there are other Python packages that you can install as well that are free and open source too, and that will handle all of that.
Cool. All right. Thank you.
There's another angle there too. So the story I'm going to tell now is based on our interaction with the journalists more than a year ago who were doing these fancy graphics. And what they immediately did is because they were typing at the command line, they just opened different terminal windows, right? So in your case, if you've got 6 cores, you could have 6 and just start them, and they would run in parallel. So I do that all the time, actually, if I'm in a rush. So it's pretty basic, but yeah.
Also, for the record, Dask is very cool, and it makes it easy to do stuff in parallel, so please check that project out.
Yeah, if you're doing the Python programming, then it's really, you just import the package, and I think it's probably only another line or two that you would add to this example that Anderson showed here in this loop. I don't have any experience with it, but I think it's just a couple lines or two. So if you're doing the Python programming at the low level, you could use all the cores in a single execution of the thing, like because you're doing multiple years. Right. Good. That's a good question. I spend most of my time running the tests. We have a suite of about 320 tests that we run every time we make a change. It's sort of like a trapeze artist trying to learn a new fancy trick. They all have nets under them, right? So out of the box, the PyTest program they run allows you to just say how many cores you want to use. And so that's very nifty. So I can see why you want it. Yes.
Okay, so I think that's all the time we have.
Okay.
But if you want to stick around, we have a couple snacks and drinks for you to hang out, ask questions, mingle. So thank you all for coming. We'll do another meetup in March. You can look for that email. If you want to be added to the email list, there's a sign-up form on the table in the back where you got the Chick-fil-A. So we'd really appreciate it if you just jot your email down, and we'll kind of get you in that listserv, and hopefully we'll see you at these future meetups. So thanks again.